What are genetic algorithms? Genetic algorithms are solution finding techniques. How do genetic algorithms find these solutions? As follows. First of all, a random set of solutions is created. Then the fitness of each of these solutions is evaluated, meaning each solution is given a grade. Is it good? Is it bad? This means we have to know what makes a good solution, or what we call the fitness function. After that, and this is the most important step, a new generation or population of solutions is created based on the previously created generation, the random generation. The first step is to select the best solution from the initial random population of solutions. This is based on the fitness functions, meaning we select the best solutions, the solutions that scored very high on the fitness evaluation. After that, there is a step called recombination or crossover. This is very similar to mating in living organisms, meaning it combines two solutions to create a third one. After that, there is mutation. Mutation is a slight change in the characteristics of a solution to create another solution. Now that we have new solutions based on the randomly created ones, we have the choice to accept or reject these new solutions. Basically, this is based on, are these new solutions better than the old ones or not? Now that we have a new population of solutions which is better than the old one, we can now replace the old with the new. Testing the problem criterion, meaning we have to know, have we reached the termination point? Is it now time to end the algorithm? This could be because we have reached the optimum solution. We have reached our goal or target. Or maybe we have reached a predefined number of generations that we are not going to exceed. Or maybe we have reached a stagnation point, meaning that the new solutions are not very different from the old ones and we're not making any progress. Or maybe we have reached a time limit. If the problem criterion is not satisfied, we will basically repeat the steps from 1 to 4 until we reach our termination point. To use a genetic algorithm in solution finding, what do we need to know? I think we need to know two things. What is the fitness? Or basically, what makes a good solution? And second, we need to know what to change. What do we modify in these solutions to reach better ones? I think this is better understood through an example. We want to draw the longest polyline on this circle. We have these points moving around, and we want the genetic algorithm to search for the longest polyline that could be drawn on that circle. So the two things that we need to know: the fitness, what are we going to evaluate? Basically here we are going to evaluate the length of the polyline. What are we going to change? We are going to change the positions of these points on the circle. We'll take another look at this definition. Definition starts with a circle. Then it evaluates this circle. Evaluates meaning it draws points on certain intervals on this circle. After that, it takes these points and it creates a polyline between them. After that, it measures the length of this polyline. This is the genetic algorithm component in this definition. It's going to do two things. It's going to mess around with these points to create solutions. Then it's going to evaluate the length. Our goal is to maximize the length. Therefore, we are going to choose the fitness to be maximized. If you want to know more about these options, I advise you to take a look at this blog. It's very helpful. Now I will start the solver. I will let it show me all the solutions. Now it's just creating random solutions. The first generation, second, third. This is the fitness or the length of the polylines. You can see they are getting better. It is reaching a solution. I would like to add some random solutions by clicking this. Just to see if there are better solutions. You see it's going back to that 5-pointed star shape, which seems to be the longest polyline that can be drawn with 5 points. See the best solution, and this is the best solution yet. I think it's going towards a perfect pentagram. I hope it reaches the perfect star before the solution stops. Okay, it stopped, and I think that's it. It reached an almost perfect pentagram. Okay, in the next video we will be looking at another application of genetic algorithms in solution finding in Grasshopper.